Okay. Please don't send your name and matric via the chat. Stop doing that, please. Please stop sending your name and department and whatever, please. So let me kindly repost the link for our YouTube. Please stop sending your name and matric to the chat box, please. The only thing that I should be reposting is the YouTube link, which I'm doing already. Okay, sorry for the break in transmission. Don't know what happened. So let me see if people are watching on YouTube. Four people. Please help me share the link. I'm no longer for those that are in the waiting room. Let them go and use the YouTube link so that the same thing will not happen again. We have be begging to join the class. So I won't admit anyone again via Zoom. So let every other person use the YouTube link. Please broadcast it to your groups, departmental groups. Okay, so let me share my screen. Okay, so sorry, Teniola Precious, kindly turn off your video, please. Teniola Precious, kindly turn off your video. So, like I was saying, so we have some basic operations, we have calculating, we have comparing. So, for comparing, I was giving an instance where you have your account. Maybe you want to make a transfer and it's greater than what you have in your account balance. So, definitely that won't be what because it's going to make a comparison. Oh no. If you can only make a transfer if what you're transferring, that is the amount you want to transfer, is less than your account balance. So there's a comparison and we're testing. So we have shifting and we have jumping. So as long as you have a problem that can be reduced to these basic operations, then you should know that such problem can be what can be solved. That is, program can be written for such problem. Yep, so we have what is called the development life cycle. You can see software development life cycle, popularly known as SDLC. Sorry, can you all hear me? Can you hear me? Okay, all right, thank you. Bolan. Okay, all right, thank you. Okay. So we have what is called the software development life cycle. So what does this software development life cycle mean? You see, when you want to develop your software, just start. saying, or don't just say, oh, I want to develop a software and you start immediately. You see, there are some steps or stages or phases that you follow, right, before you develop your software. First of all, we have what is called problem definition. For any program that you want to write, right? For any program that you want to write, either it is basic or complex, right? You have some stages that you must follow to ensure that the program is well written, right? So the first of the SDLC is problem definition. That is, you must be able to what? To define that problem that you want to solve. So I think the next slide will expatiate on each of these. So once you know the problem you are trying to solve, that's problem definition. You must understand that problem clearly. That, oh, this is the problem that I'm trying to solve. The problem has to be very clear to you. Lucia or Lucia, please turn off your video. The problem has to be what? Very, very clear to you. So that's the first thing, problem definition. The problem has to be concise and very clear. There should be no ambiguity in the problem that you want to solve. I want to write a program to solve this problem. That problem should be very, very clear. So after that, you have problem analysis. That is problem analysis. You are now looking deeper into the problem. That, oh, for me to solve this problem, what and what do I need? How do I go about it? What should my inputs be? What should the processing be? That is the stages that I need to turn my input to output, and what should the output be? Then you come up with a design or model on how you have conceptualized solving that problem. That is, oh, to solve this problem, so let me come up with this model. So this model, you see, the model can be visual to help you understand the problem better. Development to implementation, you can see that is the fourth phase. Actually, the phase where you now say, this you have um, broken down the problem. You have tried to understand the problem better using problem analysis. You have formulated the design or model. Now, the fourth phase is now where you write the program to achieve that thing, or the program to what? To solve that problem. You see, you didn't just start, you don't just start writing your code. There are some stages that precede that stage where you write your what? Your code. The first of them is problem definition, followed by the problem analysis, followed by design or model, followed by implementation, and followed by what? Documentation. So that documentation, in some cases, you see maintenance, all right? Then once you maintain or you document, and you have new changes to make to it, you can see it's a cycle. It goes back to problem definition. If you have new changes that you want to make, that's why I say that most of these bank apps, they tell you they are upgrading. By upgrading, they're adding new features, right? That's the SDLC. Before they even develop your banking app, they must have sat together to what? To understand the problem that they want to solve. They would have come up with an analysis. Okay, let's make this withdrawal, let's make this deposit, let's have transfer, let's have this. So they do analysis. Then they come up with a model. So this is what our interface should look like. This, and this. Okay, now that we have the problem definition analysis and design. Okay, so this is the phase where we write the program. So what do we need? How do we write the program for withdrawal? How do we write the program for transfer? How do we write the program for deposit? You see that they have different interfaces, right? So that's implementation. Then documentation, like I said, maintenance, they maintain, all right? If there are changes to it, then so that's how the cycle goes. So problem definition, I think I've done justice to this already. So I've explained what this means. You can see a complete, precise, and ambiguous statement of the problem to be solved. So the problem has to be very, very clear to you. That's problem definition, and it must be complete. It shouldn't be part or partial. So it has to be complete, right? And it should be concise and precise. It should be very clear. There should be no ambiguity in the problem you want to solve. The problem statement should be seen by someone else and understandable by a person. Not that this person will interpret it as an so there should be no ambiguity. Examples: program to multiply two integer numbers, very clear. If that can be a problem definition, we understand clearly that that is what we're writing a program to just multiply two integer numbers. Program to calculate employee pension, that's easily understandable. So that's another example of problem. very clear. And what are the first 10 natural numbers? 3, 4, 5, 6, 7, 8, 9, 10. You see, they did not list the numbers, but yet the problem definition is very, very clear. Write a program to sum the first 10 what? To sum the first 10 natural numbers. All right, so that is very, very clear as well. So we'll be writing a program to do that later. So analysis, you've seen problem definition, right? So analysis is a thorough examination of the problem that you defined earlier in the what? In the problem definition stage. So it involves breaking down the problem into its constituent parts and determining what is or are needed to solve it. So you can say the analysis stage is now going deeper. Now that you understand what you want to solve, so you have to go deeper by breaking down that problem into its constituent parts. So you can determine what you need for what to solve that problem. So yeah, you must be able to clearly identify your inputs, you must be able to identify your outputs, and you must be able to identify the procedures. When I say procedure or procedures, solving to problem definition very, very clear. The first number, the second number. That's process and store the results as maybe output or something. And what's the last thing? Display output. You can see this is what the analysis on how to solve that problem. So you can see another example. The example we gave there, the second one that is telling us about employees pension. You can see how you can see inputs. You need the person's employee ID, you need the full name, department, designation. Of course, at least your program should have an input, and there should be an output because you are solving a problem. So there should be something that is desired, there should be something that you are expecting, there should be a goal and procedure. How do you do it? What is the process for doing it? So you can see get active service here by subtracting current date from employment date, then multiply by the pension percentage to get what pension value. So that's how you simply what get the pension or calculate an employee's pension. So look at another problem analysis. We gave an example earlier of the one to sum the first 10 natural numbers. So you can see, look at the analysis. The first 10 natural numbers are 1 to 10. What will be your input? 1 to 10. What is the output? The summation. Procedure, that is, how do you do it? Start from the first natural number, add the next number to it, start summation, continue to the 10th natural number. Of course, that is, start from the first number, which is 1. Add the next number to it, that is 2. Summation, that's 1 plus 2, 3. Can see continue to the 10th. That means you go again. There's a loop. That means add the next number 3. 3 plus 3, 6. Store the summation 6. Add the next number 4. 6 plus 4, 10. You've gotten 10. Add the next number 5. 10 plus 5, 15. You store it. Next number is 6. 15 plus 6, 21. You store it. 21 plus 7, 28, right? 28 plus 8, 36. You store it. 36 plus 9, 45. You store it. Then 45 plus 10, 55. You store it. So that's the sum of the first 10 natural numbers. So here we actually have what is called a loop. All right. When you have a process or a set of processes or a set of steps that will be repeated for a number of times, you use a loop to take care of that. Where someone else might say, oh, this program is simple. Now, what do I do? Someone will just say, enter first number 1, enter second number 2, enter third number 3, up to enter 10th number 10. And that person that understands loop will say, no, I don't need to start entering 10 different numbers. So I can use the loop to take care of that. The loop will get my first number, it will increase itself automatically, add the second number, increase itself automatically. So don't worry, we are going to write a program to simulate this. All right. So that is that. So we talked about the third stage is model or design, right? So it's just an abstraction of the real problem, and the model defines the relationship between objects of the problem space. So we have several models that you can use for your design. And so unless I forget, class, I hope to complete this class and between this class and the next class, I've completed the VB programming chapter. And of course, there will be assignments which you have to take home and submit maybe first week in January once you resume. So the assignments, of course, if you have some questions that will be given relating to VB, so you take home and maybe once you resume in January, first week or second week, I'm not sure now, either first week or second week. So we'll be expecting you to come and submit the assignment in the department. So if you have further questions, of course, you can ask at the end of the class, but just have that in mind that I'll give you an assignment this week, which you are going to solve. And of course, that's your CA. So that's we don't give test, but that's the CA for this course. And you have just the CA and the exam. Is that clear? You can respond via the chat. Is that clear? Okay. All right. Thank you. So these are models that you can use for your design. You can see an algorithm, we have a flow chart, and we also have a business process chart. So each of these will be explained in this lecture. So now let's go to the next slide. So we talked about models that we can use, right? Is there no topic here? Title. It's supposed to be a title here. Um, okay. So it's an algorithm. Okay, let me just minimize this. So an algorithm. Remember on a model, we said we have some logical models that you can use. So you can use your flowchart to represent your design. You can use your algorithm to represent your design, and you can also use what the business process chart. So what do we mean by an algorithm? Well, it's something that we have seen, or might not just know that that's what an algorithm means. All right. So an algorithm is just a finite process or set of rules which spells out a step-by-step sequence of operations to be followed to solve a specific problem. Well, so let me just summarize this for you. An algorithm, right? An algorithm is a step-by-step procedure on how to solve a problem. So let me just, you get it, that's the summarization. An algorithm is a step-by-step procedure on how to solve a specific problem. Remember, we said it earlier that for every problem that you want to solve, that problem you must be able to break down that problem into a sequence of logical steps. So those steps that are involved in solving that problem, once you're able to identify those steps and write them down, then you say you have what? An algorithm to solve that problem. Let me just give an example. Let's say we have a class and the class has 100 students in it. So we have a class of 100 students. These 100 students have sat for an exam, and let's say they have their scores, right? Just the same way you have a class and you take a course and you get your scores. So these 100 students have gotten their various scores: 100 over 100, 90, 50, 30, 20, blah, blah, blah. And you want to find the average score of these students. Of course, this is a problem. And what is the problem? Starting from the problem definition, what is the problem? Get the average score of 100 students in a class. You can see that is very, very clear. That's the problem definition because I said the definition has to be what? Very, very clear. So now what is the analysis? You remember we said that in analysis, they are trying to break down the problem into its what? Its constituent parts. And in that constituent part, you have your input, you have your what? your output and you have your procedure. That is the steps involved in translating your inputs to output. So under that analysis, what you have under analysis is usually close to your algorithm because when you are analyzing, you are more or less like defining the steps, right? Okay, I'll do this, I'll do this. So just put it in better, just reform it in a better shape and you have it as what as an algorithm. So an algorithm is step-by-step procedure on how to solve a what specific problem. So algorithm has some properties. Your algorithm must be finite. So you can be asked, what are properties of what of an algorithm? When if when you say the algorithm must be finite, what does it mean? That is, it must end. You can't say you want to solve a problem whose steps are infinite. Is that possible? You want to solve a problem that has endless steps. That is, you just keep solving, and solving, and it will never end. No, it's not possible. So any problem you want to solve, right? You must be able to break it down in a sequence of finite steps. You must know that where problem starting from, and this is where it is what stopping. So by finite, it means it must end. So another property or characteristic is what? Definite steps. The step must be clear, precise, and ambiguous. So the steps must be what? Definite. Your algorithm should have inputs. It can have several inputs, but at least it should have an input. All right, it should have an input. It should have at least an output. Just the same way it should have at least an input, it should have at least an output. Effective. That is, the steps can be done exactly in a finite and reasonable length of time. It's not that, oh, I'm solving this problem. But to solve this problem, it runs till infinity. Why? You are solving the problem, and even if the result will take some time, at least, do you get it? It should be reasonable. Okay, you want to make a transfer. Imagine when, okay, transfer, they tell you to transfer fund is after a week. Oh, just imagine how that will sound to you. That just for me to transfer, you send money now and it's until a week before the person receives it. You see, it doesn't make sense. So it must be effective. That is, yes, there can be some delay, but at least everything should still be done in a reasonable amount of time. So that's the algorithm being effective. It's solving the problem and it's solving it in a reasonable amount of time. So given 1, 2, 3, 4 plus 5, 6, 7, 8, well, can write a program to, I don't really think that part is that very important. So algorithm notations, here is just looking at some notations that are used in an algorithm. For example, maybe you want to say you impute radius, or you want to say pi is equal to 22 over 7, pi is a constant value, and the value is 22 over 7. So there's what we call an assignment notation, all right? So what is A? You can see an arrow pointing from B to A. What this simply means is that A is equal to B. But this is just a notation, all right? So you can easily spell it out as equal to. But in an algorithm, this is a common notation that is used, meaning that assign the value of B to A. For example, if I want to say A equals to 20, you just say, you write A on the left-hand side, that arrow pointing to A will be there. Then on the right-hand side, where you have B, you have 20. Let's say A, 20, and you have an arrow pointing from 20 to A. What that simply means that A is being assigned the value of 20. That is, you should make A 20. So whenever you want to use A, anywhere down your program, it knows that, oh, A has a value and that value is 20. So in this case, what this is just doing is that it's assigning a value of B to A. That is, whatever value you have as B, assign that value towards A. That means A and B have the same value. So that's an assignment notation. Assignment, that is, assign this value to this variable. So that's what we mean by an assignment notation. That's what it does basically. Arithmetic notations, well, these are just notations that you use when you want to make or compute or perform an arithmetic operation. Plus, minus, star, slash. Do you get it? So these are what? Operations. These are arithmetic notations. And logical. We have logical notations too. Do you want to compare two things? Is this equal to this? You can see less than, greater than. That is, if the two things are not equal, if they are not equal, this is what you should do. The third one too is not equal, then you have less than, you have greater than. So I think, don't worry, the knowledge of VB program will help us to understand all this better. So a simple addition algorithm, you can see they want to add two numbers, and V1, these numbers are to be stored as V1 and V2. V1 is 1, 2, 3, 4. V2 is what? 5, 6, 7, 8. All right. V2 is 5, 6, 7, 8. 5,678. So the algorithm, you can see we need to know V1 and V2. You can see set V1 and V2, and some r is zero, that is some is initially zero. Set v1 as 1 2 3 4, that is assign 1 2 3 4 to v1, that is make v1 1 2 3 4. The third one is saying make v2 5 6 7 8, and the fourth one is saying sum v1 plus v2, that is add v1 or v2. There should be an arrow here, so the arrows, okay, that will be corrected before. If I'll be sending the slides to you, I will make sure I correct that. So V1 is 1 2 3 4. This first arrow should be here. The second arrow should be here, that is make V2 5 2 7 8. And this third arrow should be here, that is sum is equal to what? V1 plus V2, that is do V1 plus V2 and give the value to what? To sum. That is V1 plus V2, they've been added, then the value should be assigned to sum. So whatever you have as sum should be what? Displayed as the what? As your answer. Output sum as answer. So this is to sum the first 10 natural numbers. So you can see, I think I've described that earlier. I've discussed the steps. So if I want to write the algorithm now, this is what I'll write as the algorithm. You can see I saw the steps. I just listed the steps there. But an algorithm, this is now closer to what? To a programming language. It looks more like, it is now closer to what the programming aspect or the program that we're writing. It's now closer to what the programming or the program will look like. So the analysis just lists the steps. Algorithm tends to take it closer. Did you get it? What the programming should look like. So you remember in the first one, I just said set one as the first number. You can see instead of writing set one as the first number, just said I equals to 1. You can see this is closer to what to actually write as the program. Sum equal to 0. That is, set sum as what? 0. Sum equals to sum plus I. What is I? I is 1. So initially sum is 0. Sum equals to 0 plus 1. That is sum is 1. I equals to I plus 1. It will increment I. Remember I was 1 here, or I is 1 here. I equals to I plus 1 means I is now 2. If I is greater than 10, go to step 7. That is, it will stop. Can you see? Else, go to step 3. That is, if I is greater than 10, it should go to 7. Else, meaning that if I is not greater than 10, it should go to 3. Remember, I is 2, I is 1, sum is 0, sum plus I, that sum, the new sum is equal to 0 because sum is 0 here, 0 plus 1, that is 1. So here, this third step, sum is 1 because you've added 0 plus 1, sum plus I, you've added 0 plus 1. Here, at this fourth stage, I is I plus 1. It will look, what is the last value of I? 1. So 1 plus 1, I is now 2. And this one says if I is greater than 10, go to step 7. This one is telling you that if I is not greater than 10, go to 3. Because I is 2 here, it will go to 3. So to do sum is equal to sum plus I. The last sum was 1. So to now do 1 plus 2, 3. Sum is now 3. It will increment I again. I is 4. I is now 2 plus 1, 3. Is 3 greater than 10? No. So it will go to 3 again. Do you get it? You do 3 plus 3. That sum is now 6. I increase by 1. I is now 4. It's not still greater than 10. It will keep repeating. It will only stop when I is greater than 10. That's when it will come to 7. So in as much as I is less than 10, it will keep adding it to the previous sum. That is a loop. It keeps repeating. It keeps repeating. Instead of to say enter 1, enter 2, enter 3, enter 4, you can see the program is automatically increasing the values of what, or the value of I, and it is adding it to previous sum, so that in the end, the final value you have will be a summation of the what, first 10 numbers. So that is an algorithm. So the flowchart is just, I always say this, the flowchart and the algorithm are not that different, except that those you have in your algorithm, you are now representing them visually. Do you get it? So a flowchart, that's how I popularly say that a flowchart is a diagrammatic representation of your algorithm. If the algorithm has the steps, right? And the flowchart is now a diagrammatic representation. That means the flowchart is a diagram that represents those steps, the steps involved in solving that problem. The flowchart is just going to what? Represent them pictorially. That is, those structures, the steps, and everything is just going to represent them pictorially. So it's a graphical representation of a computer program in relation to a sequence of functions, that is, the tasks or the processes that are involved in it. It serves to help a person easily understand a program written by someone else. So in a flowchart, we have some standard symbols that are used to denote different operations. So the next slide will show us these symbols. So here we have the symbols and what they mean. You can see the start. That's an oval shape, oval. Oval represents start and stop. So oval, not circle. You have to be very careful. Oval, just like the shape of your egg. So that's start and stop. We have a rectangle, that's for process, all right? We have a rectangle for process, that is, wherever you want to carry out a major computation. Do you get it? That is, do this, more like a command, I equals to 1. We are assigning a value, so here is a process. We have the diamond shape. That's just like your kite, all right, like your kite. So that's for decision making. Wherever you want to make a decision, so you use that symbol. For example, here we are making a decision if I is greater than 10. So that means there the shape we are using is the what? Is the diamond shape, because you are making a decision. Here, I equals to 1. That is a rectangle. It's a process. Sum equals to 0 is a rectangle. Sum equals to sum plus 1 is a rectangle. I equals to I plus 1 is a rectangle. Wherever you are just assigning values, all right, it's a rectangle. Here we are making I greater than 10 is what? Is the diamond, because that's for decision. You are making a decision there. Is this true or not? Because every decision evaluates to what? True or false. Every decision has a condition, and that condition must evaluate to one of two possible values, true or false. I'm sorry, give me a minute to check on those that have joined via YouTube. Okay, so we have people that are watching us on YouTube. Okay, we have people watching on YouTube. So we have for input output, wherever you want to input or display a value, so you make use of the what? You make use of the parallelogram. Wherever you display a value or make an input, you make use of the what? Parallelogram. So this is a parallelogram. That's the shape, that's the symbol for input output. Then you have this for predefined process or routine. So we'll see what that means also. Then we have a connector. All right, this is a connector, very small circle. So for example, let's say you are drawing your flow chart and it continues on the next page. All right, so you have to because the next symbol cannot fit into that page. So you just put a connector, then you label it. Let's say this circle now, as it is, you just put A inside. Then on the next page where you want to continue your flowchart, you start with that connector A before going to the next symbol that is actually supposed to follow the previous symbol or the symbol on the previous page. Do you get it? So instead of having a next symbol on a page, if that page cannot contain that symbol, so I just use a connector and I'll label it A. So on that next page, I'll start with my connector A. So that symbol that could not contain the previous page, then I'll just start from it. So that connector is like it is joining two different pages that have a continuation of the what of the flow chart or that have the same flow chart. And you have the logic flow. That's simply your arrow. It can go in any direction. So remember sequence of steps. Here we have I equals to 1. It goes down, sum equals to 0, goes down, sum equals to sum plus I, goes down, I equals to y plus 1. So that continues like that. Okay. Okay. All right, so this is just an example of a flow chart for the first 10 numbers. So you can see I equals to 1, sum equals to 0. I told you we are assigning, wherever you are assigning image of the rectangle. So what this means, and sorry, before I proceed, let me see if it's on the next slide. No, it's not there. So every what? Every flow chart, every, I'm using the word every flow chart begins with a start and ends with what? A stop. I repeat, every flowchart begins with a start and ends with what? With a stop. So that's why you have this as start. Here we are assigning values. Like I said, it's a rectangle. I equals to 1, sum equals to 0. You can see is I greater than 10. This is decision. If if I is not up to 10, because we want to sum the first 10 numbers, is I greater than 10? If yes, then stop because we are only adding the first 10 numbers. So anything, maybe I is 11, we are not adding 11. That's why that is going to stop. If no, meaning that if I is not up to 10 or is not greater than 10, sum is equal to sum plus I. Sum is initially 0. Add I, which is 1, add 1 to 0. That's what this first line will do. That is 0, sum is initialized to 0, 0 plus 1. That is sum is now 1. I is now 1 plus 1. I is 1 here. So here you are incrementing I. 1 plus 1, 2. It comes here again. I is now 2 to check. Is I greater than 10? No. I is 2 now. It's not greater than 10. It's to come again. What is the last sum we saved? 1. It will add 2 to it. Is now sum is now 3. I is equal to I plus 1. 2 plus 1, 3. It will check again. I is now 3, not up to 10. It will sum it. It will add that I to sum again. I will be 4 here. It goes again. In the end, maybe I is now 10. It will do, is I greater than 10? 10 is not greater than 10, so it will still come here because it is I greater than 10? 10 is not greater than 10, so it will still come here. It will add 10 to the whatever sum that you have on ground to increment I is 11. But is I greater than 10? Yes, because I is now 11. Yes, then it comes to stop. You see that when I is 11, it's not coming to add that I to sum, it's just going to what? To stop. So if I were you, before this, I can have display sum. So there should have been display sum. I can say, okay, display sum before you stop. That is because it has done all the calculation. It has done the calculation by adding the first 10 numbers. So let it display my result for me. So which shape am I or which symbol am I going to use for that? That's parallelogram because I told you input or output is what? Parallelogram. You can see wherever you want something to be done, a calculation to be done, what do you use? A what? A rectangle. Or you are assigning variables or values, initializing values. We have what? The rectangle. Also here we have the what? The rectangle because a process is to be done, a computation is to be done. So this one is comparison. So This is an example, another example. So we'll draw more flow charts. Okay, just look at this. The order of a new customer is accepted, provided it is not more than 5,000. Otherwise, it is referred to a supervisor. An order from a regular old customer is always accepted. Define the problem. This is the problem because the problem is very clear. You have to look at it. The order of a new customer is accepted. Of a new customer, can you see? That is, we have old customer and we have new customer. The order of a new customer is accepted, provided it is not more than 5,000. Otherwise, it is referred to as. So, what does that mean? If you are a new customer and your order is not more than 5,000, it is accepted. But if you are a new customer and the order is greater than 5,000, it is referred to a supervisor. You can see logic. But if you are an old customer or a regular customer, regardless of whether your order is up to 5,000 or not, it is automatically accepted. So you can see, that means there's a condition. What kind of customer are you? Old customer or new customer? That there has to be a decision there. If you are now a new customer and your order is less than 5,000, it will accept. But if you are a new customer and the order is greater than what 5,000, it will be what referred to a supervisor. So this is it. You can see start. Next thing is check customer status. You have a decision. New customer, no. New customer, if no, that means you are an old customer, a regular customer, it will be accepted, right? If you are a new customer, there is now a condition again. Is your order, because if you are a new customer, two things can happen. It's either your order is accepted or it is referred to a supervisor. That means there has to be another condition. If new customer, you can say new customer, yes. If yes, they have to check for your order again. Is it greater than 5,000? If it is no, that is, it should be what? Accept. You can see if no, it's coming to what? Accept order. But if your order is greater than 5,000, you can see it's you have to be referred to what? A supervisor. Before I proceed, is this very, very clear? Are we still there? Am I just talking to myself? It has to be clear because we have to start programming today. This is more simple. Can you see? It's simple. So I have more yes than no. Well, if time permits, I would still give some more examples. Okay. Um, Let me think of a small example I can give. But to draw on the system, okay, let me quickly think of an example that requires decision making. Okay, let me. Can you see my screen? So there I have stats. So I want to draw a simple flow chart that will tell you to enter your matric number. So if it is 5.0, if it is between 4, let me say if it is between, I want to look at good standing and bad standing. From 1.0 to 5.0 is good standing, right? So anything below 1.0 is what? Is bad standing. So now, let me say we have a start and I want to impute the matric number. You can see I'm using parallelogram because I want to impute. So let me call this impute CGPA. Impute CGPA. So you can see, because I want to impute, I want to supply a value. That's why I'm using the what? The parallelogram. All right. So the next step, I have to check the value of the CGPA. If it is from 1.0 to 5.0, good standing. If it else, that is, if it is below 1.0, right, bad standing. So I have to make a decision there because I want to make a decision based on the CGPA. Is it greater, is it less than 1.0 or greater than 1.0? Of course, we know that the maximum is what? Is 5.0. So now I have to make a decision there. You can see my arrow for flow. And for every decision, because I want to make a decision, so this is the symbol to use, right? So let me say is CGPA is CGPA greater than 1.00, so you can see, because I'm making a decision there, is CGPA greater than 1.00, that's why I'm using that symbol. Whenever you are making a decision, that's the symbol you use. Is CGPA greater than 1.00? And for every decision, there must be a yes or no. So if yes, if the CGPA is greater than what? 1.00, what should happen? If it is greater, so I can say what? I want to print you are on good standing. Because you know wherever you are displaying output is what? Is parallelogram. So is what? Print. We can't use so print, or let me just say print good standing. Print good standing. For every condition, sorry, you have to label, I have to label this because for every condition you have a yes or no. So if yes, so this is what? Yes. If yes, there must also be a no, right? So the no of this is what? So there must also be a no. This is no. It's not supposed to be this long, but because I have another diagram there. So if no, is CGPA greater than 1.0? Yes, print good standing, right? If no, what should it print? Bad standing, because that's another output. So this is the symbol for that parallelogram. So I have what? Print bad standing. Because whatever output or input is what? Parallelogram. Print bad standing. Print bad standing. But is this the end? No. Remember I told you that every what? Flowchart must stop. Even this should have been, there should be something closing this. So now it's either it prints good standing or bad standing. Because that is the end, you just want to print good or bad standing. So now you can now stop. You can see it must end with a stop. That's the oval shape. Stop. Also, you have this coming, right? Going into it. That is either it goes through good standing or bad standing, right? You still have to what? Come and stop because every flowchart starts with start and ends with stop. So that is it basically. So I believe if you read further on the flowcharts, you'll get more understanding on that. So is that clear? Okay, thank you. Okay, so now let's go to the next slide. Take please clear screen for me. So that is it. That's introduction to programming. Now, these are important things to note. We have what is called, slide. So that's the end of the slide. So let's look at wait, can you guys see my screen? Okay, thank you. So that's the end of this slide. Then I have okay. So I will send for the VB part. Remember on the last slide, I said we are supposed to note the following. Let me FSC. Okay. Sorry, just give me a minute. I want to get a file. So for the programming part, so the last slide of the last material that I used, you will see important things to note: variables, data types, decision making, and what and loops. I will come again: variables, data types, decision making, and loops. So I have that in this slide, which I will quickly introduce you to. Then we talk about Visual Basic. So let this file open.
So, hello, can everyone hear me? Okay, thank you. So, I'm switching temporarily to my phone. The system is doing some updates, but I don't want that to stop my lecture. All right. So, we from the previous lecture or from the previous chapter, we learned about the concept of programming, and we've been able to identify its importance in today's world. So now we are going deeper into programming. So here we'll be looking at a programming language, which is the Visual Basic Programming Language, all right? So Visual Basic Programming Language, which is VB 6.0. Some of these concepts that we have, this one is doing a logical operation. This one is comparing. This one is setting a value. Here we are talking about input, output, and all that. So let's see how all these are done in a VB environment. So I will not talk much about this because I've covered this in the chapter 7. So I can share the slides with you. You can share it with your course reps, and so the course reps can then share it with you guys. So let's understand the brief history of Visual Basic. It was developed in 1960 at Dartmouth College, and the basic there simply means beginners all-purpose symbolic instruction code. It provided answer to complicated programming languages such as Fortran, Argol, and COBOL, but I won't delve much into that. So what we should understand about VB is that VB is like a tool, right, that allows you to develop Windows GUI applications, or you can call it GUI, but I like to call it letter by letter. So GUI applications, we say GUI applications, GUI. So that is the applications that have a familiar appearance to the user. Before even talking about VB, I mentioned some things. There are some things that we should know that I would prefer to introduce to us under introduction to programming. So yes, we have this. We will see it in a VB environment, right? But I want us to talk about variables, data types, loops, and decision making generally in programming. So before coming to discuss about this under Visual Basic. So what is a variable? A variable is just a location or area in the computer memory where data is stored. So it's simply the name given to the location in the program. So it's the name given to a location in the program, and it's also known as what? Variable name. Now, let me just tell us this. For example, let's say we are trying to calculate the area of a circle, or even, area of a circle. So let me use that because most of us can relate with it. To calculate the area of a circle, what do I need? I need what? Pi and radius. To calculate the area of a circle, I need pi and what? And radius. Okay. I have two options. I can say that I want my radius to be entered by the user. That is, it will ask the user to enter the radius. Or I say radius equals to what? Or I give the radius a value. Let's say radius equals to 14. If I know that the value of my radius is 14, I can just give it a value that radius is equal to what? 14. Or I say radius is equal to whatever is entered by the user. That is, in this case, I'm making that radius an input such that any value can be entered as radius. Whoever desires to enter 50 will enter 50 as radius. If you desire to enter 100, you enter it as radius. If you desire to enter 14 or 7, anything you wish to enter as the value of your radius, you can easily do that, right? So now that radius is a variable. Why? Because a variable is meant to store or hold a value. So anything in your program that stores a value is a variable. Remember the previous example that we used in the last lecture material where we had sum equals to 0. That sum is a variable. Why? Because it was storing the value what? 0. And as more values of I were added, that sum was being updated to a new value. So because it's a variable is meant to store a value. Are you with me? And the content of the variable can be changed. Initially, we initialized, if you can remember, where we were to sum the first 10 numbers. Initially, our I was 0, right? The I was 0 initially. Then after that, I was increased to 1, 2, 3, 4, up towards 10. So that I is a variable because it's storing values. Initially, it stored 1. When the content changed, it changed to what? To 2. As the program continued the execution, the value changed to 3, changed to 4, changed to 5, changed to 6. You get it up to until we get to what? 10 to 10. So that's a variable. A variable is a location or area in the computer's memory where data is stored. All right. So it's the name given to a location in the what? In the program memory, and it's also the same thing as what? As your variable name. So that means every variable you want to use, right, must have a name. Radius. Another person can say, oh, I don't want to use radius. I'm using R. Of course, it means the same thing as radius in that program that you're trying to write. So where you have pi times radius, you that you have used R as your radius, you are saying pi times R because that R already holds a value and you need to use that value. So that is a variable. I also said, so VB allows us, right? I don't want to talk, I've not yet started VB. So, but because in the last lecture material, I said we should understand what we mean by variables, we should understand what we mean by data types, and we should understand what we mean by decision making and loops. So, and because we have that in Visual Basic, that's why I just came to this aspect that, oh, let me just introduce us to what variables, loops, and all that are. So once we start with VB, we'll see how variables are used in Visual Basic. All right. So I'm not starting with Visual Basic now, just for you to understand what a variable is. And I'm making it generic. Generic in the sense that I'm not limiting the description of variables here to Visual Basic. I'm just telling you what variables are generally. In any programming language, all right, a variable stores a value. For example, if I say name equals to Abass, remember the assignment operation that we saw then. That is, wherever you say name, it already has a value Abass. So it's that Abass that will always replace name because name is a variable and it stores something. What is it storing Abass? I can say surname equals to Abass, first name equals to Rasheed. Whenever I say what is surname, to bring Abass. Whenever I say what is first name, to bring what? Rasheed. So that's a variable. A variable stores a value. Name equals to Abass. Abass is the value. Name is the what? Is the variable. All right. Surname equals to Adeniyi, right? Surname equals to Adeniyi. That Adeniyi is the value, and that surname is the what? Is a variable because it's storing a value. So that's what a variable is. So I would show us valid examples in Visual Basic. That's for later. Also, we have data types. I might not even need to use the slide there because the one I have here is basically for Visual Basic. So when it comes to data type, every data, right? Remember we have, if I tell you to give me data about you or information about you, you tell me my name is this, right? Or for example, my name is, let me pick someone. Let me go to the chat box. Oh, sorry. My name is Aishat Olayiwola. Okay. And what are those things I can tell you about yourself? You can tell me about your age. So Aishat, name. So name is Aishat Olayiwola. I have to write some things. Age, let's say 23. All right. What can you give me about yourself again? Okay, let me say your height. Height, let's say, let me assume you are a tall person, all right? So 6.0 feet, all right? 6.0, that's the actual value that I need for ignore the feet. So what can you tell me about yourself again? I think this should suffice for the basic examples that I want to use. Favorite food? Well, so let's just say favorite food. Aishat, I think Aishat will like amala. So let me put amala. Oh, she's in waiting room. Okay, let me admit some of these people. Okay, so now I'm coming to data type, right? So data type, the three most important data types, right? That everyone should know are what? String, integer, and what? The real data type. So when you say string, string is just a collection of characters. Basically, let me say text and number. So text and what? And number. Text is just a collection of characters. A string is a collection of characters. Your name, for example, let's say Ade. Ade is what? Ade is a string. Is Ade a number? Wait, are we even following? Let me know. Are we following? Are we following? Okay, thank you. So we have I just want to let us know, we want to talk about data type, but I want us to look at different kinds of data so we'll be able to understand what a data type is. You see, there's no way you would say you want to work or you want to write a program and you not work with data, right? So definitely work with what? Data. There's no way you not say you want to work with it. Even as a student of this school, you are working with what? With data. So there's no way you not work with data. So it's important for us to understand the various types of data that we have. So that's what this aspect is actually introducing us to. The various types of data that we have. Now looking at Aishat Olayiwola, that is a name. So what kind of data is it? We call it string. String. Aishat Olayiwola is a what? Is a string. Abdulhafiz Shomotun. I don't know. Abdulhafiz can be your name or your surname. Why Shomotun can be your what? Your first name. But each of them is a what? Is a string. Because a string is a collection of characters. They are not, Abdulhafiz is not a number, right? Shomotun is not a number. Abdurrahman is not a number. I'm picking names from my screen. Abimbola is not a number. Abiodun is not a number. They are all strings. So your name has a data type. That is what? String. Now let's look at numbers. Let me give two different kinds of numbers for us to understand that we have what is called the integer data type, and we also have real. That real in some other languages, they can call it float, some can call it single, some can call it double, but regardless, just know that I'm using the generic term here. It's a real data type. Now, looking at age 23, 23 is a number. It's another kind of data, different from Abdulhafiz. Abdulhafiz is a name. Based on the kind of characters that it has, we call it a string. But looking at 23, 23 is what? A number. So a data type, the data type of 23 is what? Integer. Because integers don't have decimal points. Integers don't have decimal what? They don't have decimal points. So 23, let's say Olapeju Ajala, I ask, what is your age? You tell me 23. What's the kind of data? 23 is what? Is an integer, right? 23 is what? Is an integer. So I understand that. If I now ask you what is your height and you tell me 6.0, 6.0 is not string, 6.0 is not an integer, but 6.0 is what? Is a real number. When I say real number, I mean decimal number. Why? Because 6.0 has a decimal point. So its own kind of data is different. It's a real data type. Just like we have real number in mathematics. It has a decimal point, right? That is a real number. You can see when you look at your name, based on the content of your name, it is what? A string. Your age cannot have decimal point. You can't tell me I'm 23.4 years old. Impossible, right? So that makes age an integer. Even if your birthday is tomorrow and you are currently 35 and your birthday is tomorrow, you won't tell me I'm 35.99999 just because my birthday is tomorrow. No, I'm still 35 because age does not have what? Decimal points. So whichever one that has decimal points is a real number, right? So whichever one that does not have decimal point is what? Is an integer. And so in VB, we see, I think in the next class, by the grace of God, we will see the kinds of data that we have in VB, all right? So gradually I'm introducing us to VB. VB has the string data type, that is, once you want to enter a string, VB has, VB can allow you to take care of string. Integers, yes, VB allows you to take care of integers, all right? Maybe you want to enter radius. Even your radius can be a real number. So VB is able to help us take care of that. That is numbers with decimal points. So another, I think those are the three basic data types I think we should be familiar with. So the string, the integer, and the real data type, all right? And decision making, you can make decisions in VB. So VB has some constructs to help us make decision. It has some keywords to help us make decision. All this will be covered in the next class by the grace of God. So, and loops also, I think we've seen example of loops. So you use loop when you have a set of steps, all right, that will be repeated a particular number of times, or you can see, oh, this particular operation will be repeated a number of times. So you can use your loop to take care of what? To take care of that. So see that also. So that means in next class, strictly, by the grace of God, we are going straight into Visual Basic. So we have an app. You can run it via Visual Studio, or there is also an app that you can easily, there's an app that you can easily download. The size is not much. It's as much as very much available on the internet. So what I can also do is I can send a copy of the file to your to the group. That's the course reps group. So you can share it with your classmates and colleagues. So once you share it with them, then you can use it to practice ahead of the next class, because in the next class, we'll definitely be writing programs, and assignments will be given, just as I mentioned. So, and that is going to be your CA. because your CA is 30% and your exam is 70%. So the materials that will be needed for the maybe for the assignments, you can try to get them. Okay, so I think you can get the materials at the bookshop or so. Okay, so let me just see if I can show us what the app looks like, and I will share it with your course reps as well. The question, we don't have I don't know, for those that have been getting the, don't worry, for the question, I'll get back to you before the next class. So let me just see a copy of, let me see the questions that we have already. So if you'll be answering the questions that we have already, I'll give you new questions. So you get that before next week, Tuesday, okay? That's to Tumishe Elliott. So I think we have come to the end of the class. So before the next class, I would share the VB app with your course reps. I will share the VB app with them. So they will be the ones to share the app with you guys. So if you have your system, your computer, and the app does not even, okay, the materials, I think at the bookshop, yes, at the bookshop, you will get the materials at the bookshop. So I think the app, so I would share the app with your course reps, so we can start programming as from next week, Tuesday, so that you can be able to go with the assignments. And in the assignment, for those who have gotten it already, you see, okay, I think I will explain how we'll go about it in the next class. I will explain how you go about it in the next class. You want the slides? Okay, at the bookshop, just I think it comes with maybe the textbook too. I'm not too sure, but I think it comes with the textbook. But just tell them FSC 113 or so. That's at the bookshop only. So FSC 113 at the bookshop. Or for computer science, FSC 113 computer science at the bookshop. So any other question before we call it a day? Okay. Yes. I think it comes with the textbook. Yeah. Yes. We'll put Julius. Why not type your question, please?
You are still online.
Yes, sir.
You are still lecturing.
I'm rounding off, sir.
I didn't say that.
I'm rounding off.
Say that. That's Mr. Abass. He's teaching online. So as teaching, you just meet him. After you
Okay.
come.
Yes, the assignment is to be submitted first week of January. There will be break between I think December 23rd or so and January 7th. I think, yeah, is it January 7th? I think, yeah, or is that 6th or 7th? So that's the week following your resumption. Okay, the assignment notation, can it also be an equal to? Most programming languages differentiate between assignment notation and equal to. For example, in Python now, equal to, just a single equal to is what? Is an assignment statement. For example, name equals to Abass, all right? Name equals to Abass.
That is an assignment statement. But if you want to compare, it's now double equal to. That is, the one for equal to is different from the one for assignments. Equal to is if Abass is equal to, if surname is equal to Abass. So there, the equal to there is double, equal to, equal to. All right. So in VB, we'll be able to, VB also helps us to differentiate between them. So don't worry, in the next class, by the grace of God, the logic, the operations that you have in VB, arithmetic, logical, and comparison. We'll treat all that in the next class. So do you get that, Julius? Don't worry, your assignment, you'll get it before the next class, okay? You'll get the assignment before the next class. All right. So I think at this juncture, let me just call it a day. So you guys should enjoy the rest of your day. Thank you for your time. And even when we had internet disruption, thank you for still staying online. So, all right. See you guys next week by God's grace. Bye, and do enjoy the rest of your day.